Welcome back to the Quality Task. In Part 1, we built the foundation, the workflow, the prevention mindset, the cost of quality, and the difference between quality assurance and quality control. This middle part is the toolbox, the classic quality charts. Here's the framing that makes them stick. Every one of these charts answers a different question. A Pareto ranks your causes. A histogram shows a distribution. A scatter tests a relationship. On the exam, the skill being tested is often just picking the right tool for the situation described, or reading one correctly. So we'll take each chart, read it together, and end with a clean which tool for which question summary. Let's start with the most heavily tested one, the Pareto. The Pareto chart, and it's built on the 80/20ths rule. Look at the structure. You have bars, and they're ranked from the most frequent cause on the left down to the least frequent on the right. Overlaid on top is a line, the cumulative percentage, that climbs toward 100% as you add each cause moving right. The insight the chart delivers is the separation between the vital few and the trivial many. A small number of causes on the left drive the overwhelming majority of your defects. In the software example on top, the top two causes, missing requirements and integration errors, account for about 75% of all defects. In the manufacturing example below, the top two account for about 67%. And the whole reason you draw it is the action it points to. Focus on the vital few first. That's where the biggest quality gains hide. Let's read it more slowly. Reading the Pareto, chasing the vital few. 3 moves. First, read the bars. They rank your defect causes from most frequent to least frequent, left to right. Second, read the line. It's the cumulative percentage of all defects, so at each bar it tells you what share of the total you've accounted for so far. When that line crosses roughly 80%, you've found your vital few. Everything to the left is where the damage is concentrated. Third, act on it. In the software example, the top two causes push the cumulative line to about 75%, so fixing just those two removes 3/4 of the defects. The remaining causes, UI issues, doc gaps, performance, are the trivial many, worthwhile eventually but low impact. So the rule the exam wants: fix the top causes first. You get the most quality improvement for the least effort by attacking the vital few, not by spreading yourself evenly across every cause. That's the 80/20ths rule turned into a work plan. The histogram, a completely different question. Not which cause matters most, but how is my data distributed? A histogram is a bar chart of a frequency distribution. The x-axis is value ranges, called bins, and the y-axis is how often your measurements fall into each range. So each bar's height is a count. What you read from it is the shape of the data, its center and its spread. Is the data piled symmetrically around a target? Is it skewed to one side? Is it wide and scattered, or tight and consistent? In this example, the distribution is left skewed. The data piles up near the upper limit, with a tail trailing off to the left, and the mean sits below the median. That shape is a signal. The process may be pressed against a specification boundary and isn't cleanly centered on target. The histogram is how you see that at a glance. Reading the histogram, and the key is to keep it distinct from the Pareto. A histogram shows how often values fall into ranges. The x-axis is the value ranges, the bins. The y-axis is frequency, the count in each bin. The bar heights, taken together, reveal 3 things: the shape of the distribution, where it's centered, and how spread out it is. Why you care: the shape tells you whether the process is hitting its target. A nice symmetric pile centered on target is healthy. A skew, like the left skew we just saw, warns you the process is off-center or bumping a limit, and you should investigate. And here's the contrast the exam leans on. The bars in a Pareto are ranked, biggest to smallest, and they represent categories of causes. The bars in a histogram are ordered by value along a number line, and they represent a distribution. Same bar shape, totally different meaning. Pareto ranks causes, histogram shows a spread. Don't mix them up. The scatter diagram and its question is about relationships between two things. A scatter plots two variables against each other, one on the x-axis, one on the y-axis, with each point a single observation. What you're looking for is a pattern in the cloud of points. There are three patterns to know. Positive correlation. As x increases, y increases too. The points trend upward together. Negative correlation. As x increases, y decreases. The points trend downward. And no correlation. The points are just a random cloud with no direction. The tighter the points cluster around a line, the stronger the relationship. In this example, the correlation is strongly negative. As testing hours go up, escape defects go down, with the points hugging the trend line closely. But the caution you must carry, and the exam loves this, is that correlation is not causation. The scatter tells you two things move together. It does not prove one causes the other. Let's read that fully. Reading the scatter. Testing a relationship without overclaiming. You plot the two variables and look at the direction of the cloud. Points trending up together is positive correlation. Points where one rises as the other falls is negative correlation. And a shapeless scatter with no direction means no correlation at all. In our chart, more testing hours line up with fewer escaped defects. A clean negative correlation, the kind of relationship you'd hope to find. You'd typically use a scatter during root cause analysis to confirm or refute a hypothesis a fishbone diagram surfaced. For example, does overtime correlate with more defects? Two disciplines to keep. First, always look at the plot before you trust a correlation number. A single outlier or a curved, nonlinear relationship can fool the math. And second, the big one. Correlation is not causation. The chart narrows your investigation. It doesn't close it. Two variables moving together might share a hidden third cause entirely. Two more tools round out the classic quality toolkit, and they show up constantly. First, the cause and effect diagram, also called the fishbone or the Ishikawa diagram. You put the effect, the defect or problem, at the head of the fish, and the bones branching off are categories of potential root causes like people, process, materials, and equipment. You use it during root cause analysis, very often paired with the 5 whys. You keep asking why about a symptom until you reach the underlying cause. Fishbone organizes the hunt. 5 whys drills the depth. Second, the control chart. This one plots a process's performance over time against an upper control limit and a lower control limit. The reading is binary in spirit. If the points stay inside the limits and look random, the process is stable and in control. If a point falls outside the limits, or you see a non-random pattern, like 7 points in a row on one side of the center, the famous rule of 7, the process is out of control and needs investigation, even if no single point broke a limit. Let's make the whole toolbox exam-ready with a clean decision list. When the question describes a situation, match it to the tool. Need to rank causes and decide what to fix first? That's the Pareto chart. Need the shape of a distribution. Is it centered on target or skewed? That's the histogram. Need to test whether two variables are related. Does this factor track with that outcome? That's the scatter diagram. Digging for the underlying root cause of a problem? That's the fishbone, paired with the 5 whys. And asking whether a process is stable and predictable over time, that's the control chart, with its upper and lower limits and the rule of 7. Rank, distribute, relate, root cause, stabilize, 5 questions, 5 tools. If you can map the question to the tool, you'll handle the graphic-based quality items quickly. Let's lock in the quality tools. The Pareto ranks causes and applies the 80/20ths rule, so you fix the vital few first for the biggest quality gains. The histogram shows a frequency distribution. Its shape reveals whether the process is centered on target or skewed and how spread out it is. The scatter diagram tests correlation between two variables, positive, negative, or none, while never forgetting that correlation is not causation. And the two supporting tools. The fishbone finds root causes, especially with the 5 whys, while the control chart tells you whether a process is stable over time. That's the Pareto, the histogram, the scatter diagram, and the fishbone and control charts that complete the quality toolkit. That's it for this lesson. See you in the next lesson.